This is a Wimshurst generator. It's made of two plastic wheels. That spin in opposite directions. This one in the back goes this way, while this one on top goes that way. There are a bunch of metal plates, which collect charge, and a brush that allows charge to transfer. You can see through the translucence here that the brush on the other side is on the opposite diagonal. And then there are rakes on the sides which collect charge into these bell jars. The Wimshurst mechanism is a bit more complicated, but it can generate much higher voltages. So as we saw, the device is made up of two wheels stacked on top of each other. On each wheel is a whole bunch of metal plates around the perimeter. And there's a metallic brush that goes across it. And then there are little rakes on the side, which strip the charges from the metal plates. Now the top wheel spins counterclockwise, while the bottom wheel spins clockwise. Now just like with the water dropper, at some point thermal fluctuations will cause one of these plates to have a charge. And again, for the sake of our analysis, we're going to assume we have a positive charge that starts right here. What's going to happen is this wheel is going to spin this way, and this positive charge will eventually get to about here. Now positive charges, of course, repel positive charges and attract negative charges. That doesn't make much of a difference on this wheel, but it will affect the wheel below it. See, when this positive charge is about here, it's lined up with the brush on the other wheel. So it's going to push the positive charge down to here and attract the negative charge up to here. As this wheel keeps spinning, this positive charge is going to hit this rake and get deposited in a bell jar. Meanwhile, this negative charge that was deposited here is going to make its way around to here at the same time that the deposited positive charge makes its way to here. At this point, they are right underneath the brush on this wheel. So this positive charge is going to attract a negative charge and send the positive charge back up here. And the negative charge up here is just going to reinforce that by attracting this positive charge and sending this negative charge over here. And you'll notice this is right back where we started with the positive charge up here. But now we have a negative charge here. Meanwhile, as this wheel spins, this negative charge here gets deposited on this rake, put into a bell jar. This positive charge spins up, gets deposited on this rake, into this bell jar. This negative charge and this positive charge reinforce here, and this negative charge gets deposited by this rake. This device can collect upwards of 30,000 volts, which we can show with some static electric discharge. Since the breakdown voltage depends on the distance between the two electrodes, the further apart they are, the longer it takes to build a higher voltage until breakdown.